Welcome back to the Scotti-BYTE channel, and this is Scott. Welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to talk about some Docker commands. If you've followed my channel for very long, you know that I prefer LXD containers over both virtual machines and Docker. That being said, implementation in Docker is fast and easy. Docker containers are volatile and contain a core container code base that is only replaced and can never be upgraded. A Docker container is a lean form of a Linux container that generally only contains essential code to virtualize an application and not the entire operating system like LXD, and not having to virtualize all of the hardware like in a virtual machine. So a Docker container is built to contain a core lightweight Linux distro and an application. A good example of that is my presentation entitled Run Any Linux GUI Program in a Web Browser, where I showed how to build a custom Docker container. So a Docker build command creates a Docker image from a Docker file, and then a Docker container is created with either the Docker run or the Docker compose command. Here's an example, and this is the example from my Run Any Linux GUI program in a web browser, where you can see that I'm looking at Ubuntu 2004, we're installing a couple of programs, and then we're starting an application. And that's really typical of a Docker file. In order to build a custom image from that Docker file, you're going to issue the command docker space build space -t space linux -command space period. So linux -command, because I decided to name my custom Docker image linux -command, and the trailing dot says look in the current folder for the Docker file. So you're probably used to running Docker run or Docker compose, which pulls an image from the Docker repository and then creates a container from it. Those containers might have been built like this. So here's a typical super simple Docker file. It says from node : and it has an Alpine number. Alpine is a very lightweight Linux distro, and it says in the working directory /usr/source/app, copy all the package files of type JSON over to the container, and then run the npm install, and then copy the results back into the container. Expose port number 3000 because the app apparently was written to use port 3000, and then execute the command npm start. So npm is the package manager for the JavaScript programming language, and this is a really typical application Docker file that you might actually find that builds a image that you might find on Docker Hub. So that assumes that you're going to do a docker build -t myapp space period, and basically what that does is it builds my own custom image, and that custom image is called myapp, and then it builds it from a Docker file in the current folder, and that's what the trailing period is for. And then in order to run that app, I say docker run -d for detach the image, and then -p 80:3000 that says take the port that the developer exposed in the Docker application, port 3000, and make it available as port 80 on my Docker host. Of course, port 80 is a really common port. You might need to choose a port that won't conflict on your system, so I'm sure it would be different. And then it says use the app called myapp, and or use the image called myapp, and that came from that build command. And then this is a --. I know it doesn't look like it, but it's a -- name equals super app. And basically that says when I do a Docker PS, I'm going to see a Docker container called super app, and it will say that it was built from the image called my app. So how do I use the same thing with Docker Compose? Well, I issued the same Docker run command, but not to be totally boring, I went ahead and added a -- restart equals unless - stopped at the end of it, because that's really common in a lot of Docker run commands and also in a lot of Docker Compose commands. So you just go into your nano editor or whatever your favorite editor is and do a nano docker-compose.yaml. You might want to use a code editor because getting the indents correct is very important, and getting the indents correct basically means don't use any tab characters and make sure that your indents are consistent for the things that are supposed to be indented. A code editor validates your code syntax so you don't end up having to barrel through all these errors when you accidentally leave a space out or leave something else out or put a tab in or something. Anyway, it just says container name is super app and the image is my app. Again, the port number 3000 being exposed as 80, and then there's the restart unless stop. So that's the logical equivalent of that. And to run this with Docker Compose, we just do a docker-compose space up space -d to detach, and it does the same detach, except it runs it from the Docker Compose file. So the docker-compose command is really powerful because the YAML code can contain a large number of switches, and it can also contain environment variables. But most importantly, a Docker Compose file can contain multiple containers to support an app, unlike the Docker run command that's usually designed to run only one image and create one container. So then we have the issue for non-volatile data. So non-volatile data or persistent data is data that is preserved when the container is started, and it's stored in, or stopped I should say, and it's stored in volumes. So a volume is simply a non-volatile folder inside of a container that is mapped to a folder on the Docker host that is used to store data persistently. Because remember, the actual container can't store any data. It's volatile in the sense that it goes down, everything goes away when you restart it. So this example here is a Docker Compose file for a very common application, which is Nginx Proxy Manager. And down here you see there's a volume section. And the volume section basically says that a folder inside the container called /data is being exposed outside the container to the same folder name /data. And the dot says, well, that data folder is expected to be found in the same directory where the Docker Compose file is. And then likewise, in the same level where the Docker Compose file is, we also have another folder called Let's Encrypt. But inside the folder, that Let's Encrypt maps to /etc/Let's Encrypt. So the important thing to take away from this is that anything to the left-hand side of the colon you can change. And that goes for the port numbers and it goes for the volumes. The things that to the right-hand side of the colon were determined by the developer, and you can't make any changes to those. Well, you can, but it'll just break the application. So now, how to upgrade a Docker container. So another really great thing about Docker Compose is that it provides a really easy way to upgrade a container, assuming non-volatile data is stored in external volumes. So you can do a Docker pull, and things in Docker Hub typically have an author, then a /, then the app name, and then a colon, and it has a tag. And that tag is usually a version number for the app or the word latest, which simply means the latest version of that particular app. And then you do a Docker PS command. So in my example here, I went on to my host where I run Rocket Chat, and it had two containers. It had a Rocket Chat container and a Mongo container, Mongo database. So let's suppose that all I wanted to do was to upgrade the Rocket Chat container. Well, I can use either the container ID or I can use the container name. Either one will work for the following commands. So as an example, I would do docker-compose space stop, and I would give the container ID or the container name of the Rocket Chat container. And then I would do a docker-compose space remove the name of the container or the container ID. Well, about now you're panicking saying, well, if we're going to remove the container, doesn't all the data go away? No, again, remember that the data is defined in the docker compose in the volume commands. And then finally, we do a docker-compose space up detach. And when it comes up, it will come up with the new container that we just pulled. So presumably we pulled the container for rocket chat / rocket.chat:/latest. So in summary, the Docker Hub, located at the URL listed, has over 9 million public images as of this presentation. Docker images are easily reused appliances and are great for rapid prototyping. Learn to use the Docker build command to build your own images. LXD, in my opinion, and just my opinion, is still a better option for installations that require a high degree of customization and the ability to upgrade images and the OS. Anyway, that's it for today. Please subscribe and like to the channel, and we'll see you next time.